Hey guys, welcome back to my channel. In today's video, we are going to dive into how to check whether an array is sorted or not, right? So let's say there is an array, like let's say 2, 3, 3, 7, 6, right? So these all are the elements. And I'm asking you, like, is it sorted? I'm asking you, is it sorted? You will say no, bro. Why? Because see, 7 is here and 6 is here, right? But 6 should come before 7. So that's how you said that, oh, bro, like this is not sorted, right? So the most brute force way that comes to my mind is check for all the elements, check for all the elements whether they are in the correct position or not, right? So let's say I'm standing here and I'm checking here, like, is there any element, like, is there any other element that is lesser than me in the front side, right? So I will stand here and I will go and check for all the other elements and I will check, like, I will do a like if condition, and if ARR of, let's say, J is the second loop, if it is lesser than myself, let's say I'm like see this is I and this is J, let's say. So if ARR of J is lesser than ARR of I will say, bro, no, this is not a sorted array, right? But if this condition is never executed, that means it's a sorted array, right? So it will be of n square. Why? Because for each element, you're going and checking with all the other elements, right? You might argue like, oh, okay, so see, if I'm here only, I'm going to check for n minus 1, right? But if I'm standing here, I won't go backside, right? I will just go and search in the front side only. Still I can submit to like of n square solution, right? So that's the brute force way, right? So I cannot think, like a more brute force, way other than this. So the brute force way is actually to get the answer in O of n square. So there is something using which you will get the answer in. Space will be, you will be taking of n, and also you will be taking a time of n. Sorry, shit, of n, right? So how? See, I have mentioned space, right? So you might be guessing, like I will just sort this array. Let's say I'm not okay. This will also take of n square, because see, if you are using this bubble sort, insertion, or like whatever the sorts are there, I mean basic sorts, right? Basic sorts that are taking the time complexity of n square. If they are using anywhere, the overall time complexity will be of n square. Okay, so I was wrong. Time complexity will be still of n square. So like let's say I'm doing in this approach, right? So I will just first sort it, then I will keep it in a separate array. Then what I'm going to do, I got this array and I got the sorted array. I will just go and check for each indexes whether, like let's say this is sorted, SOR, let's name it, and this is ARR. I will just run a loop from 0 to n minus 1 and I will just check whether ARR of I is equals to SOR of I or not, right? So if it is, sorry, if it is not equals to, I will check, is there any index in which the elements are different? If there is some index, then I will return like, okay, I will say like, oh, there is a difference. I mean, this array is not sorted array, right? So I will just say that, okay, this is not a sorted array. But again, see, it's taking a time complexity of n square, and again, it's taking a space complexity also. So I'm trying to, reduce the space and time, both. See, so anyway, I have to travel from 0th index to n minus 1th index, right? Because each of these elements contributes to the array, whether this array is sorted or not, right? So anyway, I have to check for all the elements. So basically what I'm saying, I will have to visit all these elements once at least, right? So time complexity, it will be anyway O of n. It won't be lesser than O of n. But previously we have seen that we were taking time complexity of n square. So we can reduce this, right? And of course for space, we don't need any space. So without using an extra space, we can solve it, right? So let's see how. I'm going to check for adjacent elements. You might be asking like why adjacent elements, like how does it work? So let's say I'm keeping two pointers like here and here. Let's give them indices 0, 1, 2, 3, 4. Okay, 3, 3, 4, right? So I'm checking whether these two are in the correct order or not. Okay, they are. Okay, so let's move forward. Let's keep the pointers here. Let's check like whether 3 and 3 are these elements in the correct order. You might be saying they are same. So are they sorted? I would say yes. I mean, considering that sorted is basically it will be in the increasing order, but still same elements may be there, right? So yeah, it's in the sorted order. Yes. Uh, so let's move forward. 3 and 7, of course 3 is lesser than 7, right? Let's check for 7 and 6. Oh, 7 and 6, for 7 and 6, 6 is lesser. So see how this graph have become, like it went on increasing, 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 and here it's like decreasing. So bro, this is not a sorted array, because see, the sorted array graph should be like this. It should be like only increasing. So yeah, that's what we are checking. We are checking for two indices and we are checking whether the graph is increasing or not. That means whether ARR of I is lesser than ARR of I plus 1 or not. I plus 1, what is I plus 1? The next element. If it is lesser, then bro, you are good to go. But the moment it becomes, sorry, I should give equals to also, because see, condition 3 and 3 both are equal, right? So even if they are equal, let it be. But the moment the element is greater than the next, then we will say, bro, something wrong. I mean, this array is not sorted, right? So let's code it. Okay, so let's say an array is given to you. Let's keep the elements same. So the elements were 2, comma 3, comma, sorry, yeah, 2, comma 3, comma 3, comma 7, comma 6, right? And the size is 1, 2, 3, 4, 5. Okay, n is equals to 5, right? So see, I have written this if is sorted. This is a function that we are going to fill right now. If it returns true, I will be printing yes, or else I'll be printing no, right? So let's say, so I'm just going to iterate from I equals to 0 till I is lesser than n minus 1. I plus plus, why n minus 1? Why n minus 1? Like, it should go till I is lesser than n. But why n minus 1? Because see, we are checking whether ith index is lesser than I plus 1th index or not, right? So we are checking with the index that is in the forefront of me. So can I check the last index? No, right? Because see, if I am going to check the last index, I have to compare it with the next index. So there is no next index. So I will get an error. So that's the reason we are checking one step backward. We are going till I is lesser than n minus 1, right? I'm going to check whether ARR of I is greater than ARR of I plus 1 or not. If it is the case, that means there is some element that is lesser than me and it's sitting just in front of me. So it's clear that the array is not sorted. So let's return false. Let's say that, bro, this is not sorted. And let's say we couldn't get into this if condition and we have iterated from 0 till n minus 1 index, sorry, till n minus 2 index. I mean, I is lesser than n minus 1, right? That means from 0 till n minus 2 index, right? So we have iterated, but still we couldn't find any element, bro. Like, we couldn't find any condition that satisfies this. So I will just return true. So that's how we are going to solve this. So let's delete everything. Okay, there is some red. What is this? Okay, so the problem is here. There is a slight mistake in my bracket. So let's remove that extra closing bracket and then let's try running this. Okay, it's not sorted, that we know. Okay, let's change this. Let's change this into, let's say 5 2 3 3 5 6. It should come that it's sorted, right? Yeah, it's sorted. So that's it for the video. If you like the video, please hit the like button. Please subscribe to the channel, and until next time, see ya.